Welcome to The Explainer, where we take on these, well, pretty complex technical documents and turn them into something that actually makes sense. So when you see a word like Paris, you know what it means from context, right? It's obvious. But for a computer, the web is just this giant, chaotic sea of words with no real meaning attached. And that ambiguity, well, it's a huge, huge problem for any software trying to make sense of it all.
So today, we're going to dive into a W3C technology called OWL2 that's designed to solve exactly this. Here's our game plan. We'll start with the problem itself, this web of words. Then we'll see how OWL gives data some much-needed meaning. We'll look at the actual building blocks, see the power of what's called reasoning, check out the different tools for different jobs, and wrap it all up with a look at the future it's building.
All right, first things first, let's really dig into this problem of ambiguity on the web. You know, the thing is, the web was really built for us, for humans. But computers, they don't see meaning. They just see characters and links. So while you and I can tell the difference between Paris the city and Paris a character in a play, a computer is totally lost. For software to do anything useful, it needs things to be precise, predictable. Without that, it's basically just digital chaos.
Okay, so this is where our solution comes in, the OWL2 Web Ontology Language. Think of it as a special language from the W3C that's built to add a layer of actual knowledge, of real meaning, right on top of all that messy data.
Right, so OWL is a language used to build something called an ontology. And I know that word sounds a little academic, a little scary, but it's not. An ontology is really just a formal, precise description of some part of the world. It's a way of defining things and how they're related so that a computer can finally understand what's going on. And this is a really key point to get. OWL is not a programming language. It doesn't give a computer a list of steps to follow. Instead, it's declarative. It just describes a state of affairs. It says, this is how the world is. And it's also different from a normal database. See, a database works on a closed world assumption. If it's not in the database, it's false. But OWL uses an open world assumption. If something's not stated, it's just unknown. And that little difference is everything, because it leaves room for the computer to discover things. Okay, so let's get into the nitty-gritty. How does this actually work? The best way to get a feel for it is to use a really simple example that comes right from the source doc, building a family tree. So the most basic building block is something called an individual. And that's really just a fancy word for a specific thing. A person named Mary, the city of Paris, whatever it is we want to describe. It's our subject. Then what we do is we group these individuals into classes. A class is just a category, a bucket for things that have something in common. So our individual Mary, she can belong to the class of person, but also the class of woman. Easy enough, right? Now this is where it starts to get really powerful. We create rules, which are technically called axioms, that define the relationships between our classes. So a rule like this one basically says every woman is also a person. We're building a hierarchy, a structure that the computer can follow. And of course, individuals don't exist in a vacuum. They're related to each other. We describe these connections using properties. So we can create a property called hasWife to link the individual John to the individual Mary. We're literally drawing lines between them. And it's just as important to say what can't be true. We can state that the classes man and woman are disjoint. All that means is that nothing can be a man and a woman at the same time. This kind of rule is super important for preventing logical mistakes down the road. Okay, so you might be wondering, why go through all this trouble to state what seems, well, kind of obvious? And this, my friends, is where the magic happens. This is the big payoff. So if a computer knows all these little rules we've set up, what can it figure out all on its own? This is where it gets really cool. All right, let's play this out. We've told the system 2 rules. First, every mother is a woman. Second, every woman is a person. Simple enough. Now, we give it just one, new piece of information. Mary is a mother. Now watch what happens. And there it is. The computer itself connects the dots. It knows that because Mary is a mother, she must also be a woman. And because every woman is a person, therefore,
The computer knows Mary is a person. We never, ever told it that directly. It figured it out. That's inference. That's the whole point.
But here's the thing. Using the full power of OWL2 can be, well, a lot for a computer to handle. It can get really intensive. So it's not a one-size-fits-all solution. That's why it comes in different profiles.
You can think of these profiles as leaner, more focused versions of the language. They're designed for specific kinds of tasks. Basically, you trade a little bit of the language's expressive power for a massive boost in performance and speed. This is what makes AOL practical for dealing with gigantic, real-world datasets. So you've got these three main flavors. You have OWL2EL, which is amazing for handling complex categories. Think huge medical databases like SNOMED CT. Then there's OWL2QL, which is all about querying big databases really, really fast. And finally, OWL2RL, which is a total workhorse for applying rules across massive amounts of web data. The bottom line is, there's a right tool for the job.
All right, so let's pull back and look at the big picture here. What is all of this building towards?
Well, OWL2 is a foundational piece of this grand vision called the Semantic Web. The goal is to transform the web from just a bunch of documents for people to read into a true web of knowledge, a web where information has clear, defined meaning so computers can actually understand it and reason with it. We're talking about way more powerful search, smarter AI, moving from a web of documents to a web of knowledge.
And that really brings us to the final crucial question. What becomes possible when the web doesn't just link to information, but actually understands it? Think about that for a second. What happens when our digital world can finally reason about the data it holds? That's the future OWL2 is helping us build, one logical step at a time.